this section, we're going to be looking at some of the differences between linear and exponential functions. So all of chapter 5, we had mainly been focusing on our linear functions, our y equal to mx plus b, and how those go, and our growth being that slope. In exponential functions in 6.1, we are now looking at these equations that are instead y equal to a times b to the x, something a little bit of that form, where our growth, instead of it being adding that slope to our value, we're multiplying by this growth factor b. So we're going to take an example here to look at kind of what happens when we have these two different types of growth. So for our problem, we are told that a bicycle company produced 3,000 bicycles in 2014, its first year of business. And then in 2019, the company made 12,000 bicycles. So now to start, we want to take the information that we have been given here and write two ordered pairs of our form xy, where x is going to be our number of years after 2014, and y is the number of bicycles produced in thousands. The in thousands just makes our numbers a little bit easier to work with for our equations. So our first one, we were told that in 2014, they made 3,000 bicycles. So our ordered pair, xy, this would be 0 years after 2014, comma, 3 for our 3,000 bicycles. Our second ordered pair, we're going to be working with our data for 2019 that we were told that 5 years after 2014, the company made 12,000 bicycles. So we have the ordered pair 5, 12. And now we can sort of see this on this graph that has already been given to us over on the right. These two ordered pairs are where the line and curve that we have cross. That we have the first one being 0, 3, and that second point as being 5, 12. That we can see with this. And now to start to get our equations for these two graphs, the straight line on our graph here on the right, that is our linear graph. We've seen a lot of those throughout chapter 5, our straight lines. And then our second graph that's on here, that is the exponential graph that models this information. And for part B, we want to find the equation, y as a function of x, if we assume that the growth for this company was linear. We don't necessarily know that it's linear. We weren't told any of that information, but we can write an equation, what it would model, if it did happen to be linear. So, to start with our linear equations, we want to be able to write it as y equal to mx plus b, and we need that slope m and our y-intercept b. Well, m, that is our change in y over change in x, so y2 minus y1, 12 minus 3, over x2 minus x1, 5 minus 0. So then that gives us this to be 9 over 5, which then I could leave it as a fraction form 9 over 5, or I could write this one as being 1.8. The second part for our linear equation that we need is our y-intercept b. We've already been given this actually from our information that we're told that we have the ordered pair 0, 3, which means that b is equal to simply 3. So now we can write our linear function that would model this bicycle company to give us that we have y equal to 1.8x plus 3 as our final answer for that. For part C now, what we want to do is find the equation of the exponential function that goes through these two ordered pairs. A model for y as a function of x if we assume that the growth was exponential. So now, a little bit for our exponential equations. They look something kind of like this, y equal to a times b to the x, where a is our initial amount. In this case, initial amount is always going to be the y-intercept. And then b is the growth factor. And an easy way to go about this when I have two ordered pairs is to figure out what do I need to multiply that initial y value of 3 in this case to get to our second y value of 12. And that is then that b, the growth factor value. So here we have that our a is equal to 3 for our y-intercept. And then b, well, I need to think about 3 times what, in this case b, is going to be equal to that second y value of 12. Well, I can solve this equation here, divide both sides by 3, and we get that b is equal to 4, that is our growth factor. This part here means that every 5 years, we multiply by 4. And it's 5 years because that ordered pair 5, 12 means that it took 5 years for us to be able to multiply by 4 for our situation. So now, to go about writing our exponential model for this, we're going to have the equation y equal to 3 times 4 to the x, but I'm not done yet because how this looks right now, this would mean that we multiply by 4 every single year that goes by. But I only want to multiply by 4 every 5 years, so this exponent needs to end up being multiplied by 1/5 to undo that multiplying by 4 every single year to make it only happen every 5 years instead. So then this would be our exponential model that would represent the bicycle company. So now for our last part here, we want to know how many bicycles does the linear model predict for 2024? And then how many bicycles does the exponential model predict for 2024? So to start, for both of our models here, we wrote them as our x's being years since 2014. So I need to think about how many years is 2024 since 2014. This one happens to be, it's 10 years. So we want to replace our x in both of these models with 10. So for our linear one, we're going to have that y is equal to 1.8 times 10 plus 3, which then that is going to give us to be 18 plus 3, which we could then say is 21. And this would be 21,000 bicycles. Our exponential model that we just got here we have that as being y equal to 3 times 4 to the x times 1/5 power, and we're replacing our x with 10. So I have 10 times 1/5 in the exponent. So then 10 times 1/5 is just 2. So we have 4 squared there. So then 3 times 16. This gives us 48, to give us 48,000 bicycles. And now lastly in this, we're asked which model seems more reasonable. Depending on what we're working with, both of them could be reasonable. We don't really have a ton of information about this bicycle company. However, an exponential growth does become very rapid. So this one that we went from the 12,000 after 5 years to 48,000 after 10 years might be a bit too quick for the growth of a company like this, where a linear model might seem more reasonable for long-term type of growth. But an exponential model for the short term might be reasonable as well to look at.